Okay, so we've got two horizontal lines, two vertical lines. Horizontal lines are x equals -2 and x equals your b variable, depending on the number of letters in your name. And y equals c, y equals a are the two horizontal lines. And I don't know horizontal from vertical. Hopefully I haven't totally ruined your concept of horizontal versus vertical. But the y things are horizontal lines, right? X is your horizontal coordinate, giving you vertical lines. Okay, now I labeled them as they should be labeled, with x going that way and y going this way, but I used the wrong words here. So we can easily estimate coordinates of points. So if you're asked to find the equations of these straight lines and these parabolas, then if you have 2 points on a straight line, you can get the equation. So we maybe choose this point and this point. That'd be a good choice because they're further apart than these 2 points or these 2 points, reducing the percent uncertainty in your estimates. Anyhow, we won't go into too much detail on that. And as I said, I'll pretty much accept any reasonable estimate. If I ask you to do a slope equals slope thing, you're going to need a third point and a couple of fundamental triangles, and everybody should understand how we do that. If not, we can review it. Okay, and maybe this point and this point, we estimate the coordinates of those points, and then we can easily get the equations of the two lines. Slope equals slope method always works. And as I said, I might potentially ask you to do one of them by the slope equals slope method and do the other by any method you wish, because the other method's important too. Slope equals slope method gives you more insight into what the equation means. So, on a parabola, the easiest way to get the parabola is to first estimate the coordinates of the vertex, because you know that there are two forms of a parabola, this form and the vertex form, okay? And the vertex form tells you the coordinates of the vertex, that's BHK. And you should understand why in terms of transformations. And then you have an A coordinate out in front that's the same as the A coordinate, or the A parameter up here. Now the B and C parameters are more complicated in their relationship to H and K. You got to expand this and simplify it to figure out what B and C would be, but there's the equation of your parabola. Now to estimate the points on the blue parabola, we estimate the vertex. I estimated 2014. It's probably not a very good estimate. And this point here, these points here, the 2 points where the parabola meets the y equals 12 line and the x equals 37 line, are pretty close to the corner of this rectangle. Incidentally, the corners of the rectangle would be these, just for reference. So I'm just going to use those coordinates, because to do otherwise I'd almost have to estimate to tenths and stuff like that. Now, actually this might be 38 or 39, so maybe I'm going to change that. Let's see, it's easier to change a 7 to an 8 or a 9. I'll say 38. But it's only a fraction of a unit above the y equals 12 line because of the scale between 12 and 19. So I'm not going to mess with that. Okay, so anyhow, I've got the vertex and a point of the blue parabola. The vertex is 2014, so y equals a times x minus 20 squared plus 14. And that's very easy. You see, this is a horizontal shift and this is a vertical shift. You have a vertical stretch factor of a, and you don't know what that is, and you're going to find that by plugging in the coordinates of this point and solving for a. So plug in the coordinates of 38, 12. I'm writing it in abbreviated form. You get 12 equals a times, and I'm doing it again, 38 minus 20 squared plus 14. Solve for A and you'll have your equation. Now, I'm not going to go through the arithmetic of that. Just for reference, I'll tell you that 38 minus 20 is 18. 18 squared is 324. Subtract that, so it's going to be negative 324 over 12. Okay? So, I said negative 324 over 12. Doesn't follow at all from what I said. It's negative 2 over 324, and I don't know where I got 324 over 12. Okay? Work it out. If I'm wrong, find somebody to complain to. Point it out to me, whatever. Okay? Of course, that reduces to 1 over 162, negative 1 over 162, which would be like 0.006 something. Okay. So, there's a lot of content there. So, kind of a good problem. Now, what else can we do with this? Well, we could multiply all three of these functions together, all four of them, and get a polynomial of degree 6, couldn't we? And then I could ask you to graph it. Okay? I probably wouldn't do all four of them. I'd probably maybe do the 2 lines and one of the parabolas. Now, if I do the 2 lines and one of the parabolas, that'd be like some linear expression here, some linear expression here, and a quadratic expression, right? Would that quadratic expression be reducible? What does it mean for quadratic expression to be reducible?
It's made up of 2 linear.
I'm sorry?
It's made up of 2 linear.
It'd be made up of 2 linear functions, but how would you find them? And how do you know whether this parabola is reducible or not?
The quadratic formula.
Well, you could use the quadratic formula. You'd have to get the equation before you could do that, right? And you know, maybe you would have the equation, but you can tell just by looking at it that it's reducible. Because if it has 2 linear factors, what else do you know its graph has?
Zeros.
2 zeros, right? So if it has 2 zeros, it's going to have 2 linear factors, isn't it? It's an if and only if thing. If the discriminant of your quadratic expression is positive, it's going to have 2 zeros. And you know that because, well, at least, you know, most of you handed in the homework and had that right, more or less. Some of you missed it. So this parabola is going to have 2 zeros. You can tell by looking at it. This is above the x-axis, right? And it opens downward. That means it's got to go through the x-axis in 2 points. So this is going to give you a reducible polynomial. Okay? Make sense? If I multiply this equation by this equation by this equation, it's going to be a reducible, it's going to be a product of 4 linear expressions. Because this is going to give you a linear expression, this is going to give you a linear expression, and since this has 2 zeros, it breaks into 2 linear expressions. Okay? Now if you did the 2 lines times this parabola, this parabola, does this parabola have any zeros? Is it reducible? No, it's reducible if and only if it has zeros. Okay? So you would have an irreducible quadratic times 2 linear factors. Okay? And the quadratic can't ever equal 0. The linear factors will equal 0 at some 2 different points, or maybe at the same point. So you can write the polynomial. Of course, that comes out of the homework you had today, and we'll maybe talk about that more next time, depending on what I see when I look at your homework. Okay? Okay, well, you see, you can do all that with this picture. So that picture brings a whole lot of things
Miss
together.
Rosa, you never know who I am, remember?
And if you can do all this, then you're probably in pretty good shape, although there are other things you gotta know. Okay? Now, if you look at what I just handed out, and let's cut this off.